Okay, I'm gonna sort of do a quick demo of another way I've already done in one of the previous videos, how to trace a shot on the PC board. And I've done it on the same, PC board, where I've got different semiconductors, diodes connected in parallel with resistors, electrolytic capacitors, and non-polar capacitor. I've got basically two wires where I can make a shot. I can make it right at the edge here across this diode, or I can make, I'll use this center one, and I'm going to make a shot across 1N4148, which is a fast switching diode. I will solder it, but let me show you the setup. Okay, basically the setup is I'm going to use a thermal imaging camera, and you can see over here that ambient temperature and the temperature on the board, because I got it right in the middle, more or less, pointing. Okay, is about 24 degrees or so, which is the ambient temperature. So there is nothing connected. Now, basically, I'm going to feed very low voltage, selected about 0.8 volt from this particular unit. Okay, I can adjust anything from 0.1 volt to like 30 volt. But in this case, because realize one thing, I can't use very high voltage, because just in case maybe these microcontrollers or something else connected and they operate at 1.5 volt, 3 volt and so on. So I've chosen 0.8 volt. Except what I've done is adjusted the current on this unit that it gives me about maximum 1, something ampere. Okay, so that unit is driven with my state-of-the-art power supply, a dual power supply, where I can also monitor amperage and current very precisely also at the same time. But nonetheless, everything is being pre-aligned because of the time factor. And what I'm going to do right now, I'm going to switch on the thermal imaging camera. And the thermal imaging camera is measuring 24 degrees because there's nothing connected. Okay, you with me? So long. Okay. And now over here it shows me maximum temperature. You will see at the bottom. Okay, but nonetheless, okay, let me just connect it up again. All right. Now what I'm going to do is I'm going to join this, simulating a shot. Okay, so it's joined. So now I'm gonna connect, basically I'm gonna power this board with my specialized unit, as I explained, with this unit that state of art that we use for current, voltage and short circuit protection. Okay, so it doesn't do any harm or damage to the board that you're testing. Okay, so now I'm injecting basically the voltage into the let's see, now I'm going to switch on the thermal imaging camera. All right, and I can see it's already, let's see. Okay, watch it now. It's already 59, something degrees. Okay, you can actually see it. Let me just, and you can see it. You can see the spot weights. I'm gonna disconnect the power and watch the temperature. Watch the temperature going down. Okay, 27, something. Okay, and let me do this again. Okay, and again. All right, so now I'm going to connect a direct shot and watch the temperature jump straight away. Okay, it's going to pick it up. Okay, 40 something degrees, and watch it's showing me in the center of the board. Okay, it's showing me the spot, and it's showing me over here in the center of the board, and it showed me 47, 48 degrees. So now I got to find out, I'm going to cover now the resistor, I mean the wire, the diode, okay, and you can see over here, but watch now, it becomes sort of concentrated right on that particular spot, because that's where the short is, and here it is, that is the wire, and that's about, right now, let's see what's the temperature, it's about 42 degrees. Watch now, again, when I disconnect the power, I'm just going to disconnect the powering. Watch it. Immediately the temperature drops to like 27 degrees. And you can see the patch becomes much bigger, larger, because it's measuring now, seeking for the highest temperature. Let's put it that way. And watch when I join again, how it gets concentrated to one specific point. Can you see it? Okay, one more time, I'm going to disconnect. Okay, and you can see over here. Okay. There we go. Okay, let's see again. Let me just try to put that right in the center. Okay. So it's all right. It's 54 degrees. Watch now what's going to happen. I'm going to disconnect it, okay? I'm going to disconnect it, okay? Now it's going to become, it's cooling off. Now, basically, the camera is searching for a highest sort of point, a highest temperature, should I say. And the highest right now on the board measured is about 20, and it's equal, basically, on the whole board. Watch now when I connect again. The actual connection, okay? Watch it immediately, okay? Let me do it from here. Watch the temperature change, okay? It becomes concentrated, and it immediately picks up a shot, and the circle becomes much smaller. In other words, that's the highest temperature on the board. And it's pinpointing exactly where it is, and with tweezers, I can actually pinpoint, and I can actually block. I can actually block the diode. Let me just try to do this. Can you see I blocked the diode? Yeah, is the tweezers. Watch now. It becomes immediately. It's telling me that there is definitely something wrong. The temperature is too high from the rest of the board. The blue is the rest of the board temperature. So, and over here I can see on the rest of the board, my temperature is about 19 degrees. And over here, that pointer is basically 45 degrees. And this one here, where the highest temperature is, it's exactly 57 something degrees. So I know precisely, I can pinpoint to like millimeter on the board where the shot is. So that's how we basically, with the specialized unit that we use, and power supply, we can trace on any board. This is just a demo board, as I said. But any PC board that has got a shot, by injecting specific low voltage, and I start from very low current until I actually pinpoint the actual spot on the camera, on the thermal imaging camera. So that's another way of sort of tracing the shots, and which is also quite effective. But a lot of people do not have the thermal imaging cameras or the specialized unit, which is that I've built myself. So it gives me versatility, as I said, from 1 volt to anywhere up to 30 volt, and then from or wherever ampere to maybe 3 ampere, 4 ampere, I can generate with this particular unit. So depends, of course. You can't just start injecting the power into PC boards, sophisticated PC boards and things like that. Let me just get one PC board here. like say for example, you got a PC board like this, you can't just start injecting any voltage, to try and do the tracing of the shorts and so on from where the power supply originates. You have to know your sort of bit of electronics and develop your own sort of techniques. Because as I said, the trick to a story is this particular unit combined with my sort of power supply, universal power supply, that I can control, and I can apply the actual technique to just any circuit, because I can without sort of damaging the actual circuitry, I can I'm trying to find the right word, according to the board and according to the chips surrounding that particular sort of section or that particular part of the PC board or the whole board, I can apply it to anyone from, as I said, from 1 to 35 volt. So you've got to be very careful where you use and how you use. You have to have a bit of experience. Otherwise, you can apply all other surrounding chips by, say, maybe applying 3 volt, but yet you must use, like right now, as I said, I use below 1 volt, sort of injected voltage over here, in order not to be able to damage maybe some sensitive chips which operate on 1.4 volt, 1.5 or so on. All right, on that note, I hope you are with me, whoever you are watching it. Yes, that's another way. Probably in the next video I'll do another way again of how do you trace the actual shots on the sophisticated surface mount PC boards and whatever. And I can find whatever, whether it's a chip, whether it's a capacitor, resistor, transistor, wherever it is, shooting with ease, no problem. Thank you for watching Barto's sort of short circuit tracing with the thermal imaging camera. Thank you.